Good morning, good afternoon, everyone, and welcome to another Coffee Break webinar series. Today's topic of discussion is going to be the part 2 in our automation series, covering the application sequencer in SignalCalc 900. So the agenda for today, we're going to talk about the application sequencer in broad strokes, give you an overview of what its capabilities are. Then I'm going to delve into some examples using the user interface for the application sequencer and go over some simple ways to automate tests, sequence tests, and then get into some of the slightly more advanced areas using the application sequencer user interface. And then I'm going to talk about the new exciting feature we have, which is application sequencer scripting. And this is a way to, instead of using our user interface to, use a text file to generate your own sequences and to automate our software using a script that you write in Notepad or your favorite text editor. And it's a way that lets you automate our system a lot faster, especially particular if you're doing more complex automations. I'm going to start with the application sequencer. So the application sequencer as a whole, the functionality as a whole, whether you're using from the user interface or from the scripting language, it allows you to pre-program different tests to execute sequentially, and the tests can be pre-configured to run automatically without user interaction. So you can say, I want my sign sweep, then a random sweep, then a final sign sweep to all be executed one after the other, and you can click start and it'll run them without the user having to interact with the software anymore. The sequencer also has the ability to use logic. So conditional statements, you can say, if my test passed or if my test stopped, then do this, or if my if my test aborted, then do this. We also have the ability to send out email notifications through the sequencer. So, if a test failed, then you can have it send out an email notification saying the test failed, or if a test succeeded, if you're running a test over the weekend, you can have it send an email out when that's done, so long as you have, of course, you have internet access to do that. The test sequencer also works with the relay card, which is a small little digital I/O box that we can communicate with and our software talks to. I'm not going to go into details about the relay box itself. That's going to be part 3 of the automation series. But I'm going to get into some detail of how we use the relay box because it is used through the application sequencer. So overall, the sequencer acts as a supervisory programmable interface to allow you to program our software. So you can, on one level, you're programming a particular sign profile or a particular random profile to run. The sequencer lets you create a supervisory sequence on top of those random or sign or shock profiles and lets you sequence them and automate them along with the ability to automate other lab equipment through the relay card. So I'm going to get into some examples of how this works. I'm probably going to keep it quite simple today, but the functionality goes pretty deep. So I'm going to switch over to SignalCalc 900 now. Here we are. So here I have SignalCalc 900 open on my screen, and I've got 2 tests here. I've got a sign test and a random test. And the first thing I'm going to do is I'm going to open application sequencer and show you how to sequence these tests to run one after the other. So the application sequencer is accessed from the DP menu. I go to application sequencer. Now this is a licensed option, so as long as you have the license for it, you'll see the menu option there. And this is my the application sequencer. So I'm going to hit edit and quickly build up a sequence that's going to execute my sign test or my random test and then my sign test. So I hit edit, and this is the editing window. This is the user interface of the application sequencer editor. So I'm going to hit the plus sign, and I'm going to go to test commands. This is where I sequence my commands on the left, in the left-hand column here, and then on the right-hand column here is some custom settings for each particular command. So first I'm going to say test commands, open test. And then if I click on the open test, I can tell it which test I want to open. So I click on my test button, and it brings up my manage test screen which I've only got 2 tests now. So I'm going to open my random test first. And then I'm going to add another command, test commands, start initialize test, and then test commands, start test. Now in the start test command, I'm going to click on that and go to the options on the right and say wait for completion. And what that's going to do is it's going to make sure that I actually start the test and then wait for it to complete before going to the next command in the sequencer. I'll get into an example of why you might not want to do that in a few minutes here, but for now I'm going to have it wait for the test to complete. And once the test is stopped, then I'm going to end my test. Okay, so this is basically the programming the actions that you would normally take in the user interface. You open the test from your manage test screen, you initialize, start, and end the test. Now this is for the random test. Oh, and then I'm going to close the test. One last command here, close test. So this is for my random test. Now I want to do this for the sign test also. So I can shift click and select all my rows here, and then right click and say copy. And I have a copy down here, and I'm just going to go to the second open test and select my sign test. Okay, so now I'm opening my random test, I'm running it, then I'm opening my sign test, and I'm running it. Hit OK. If I wanted to save this sequence file, I could do that. Hit save. We save it out to a file that you can open up from the sequencer. I'm just going to hit execute. And you can see as it's running, the line that you're on currently is highlighted in green. So it opened up my random test. It initialized, it's starting. I can shrink this a bit so we can see what's going on the screen. And you can see the test is running without any user interaction. There you can configure the test to do that, and that's what I've done here for this random and this sign test. And once this random test completes, I have it configured to run for about 30 seconds total test time, so it's got about 15 left. Then it's going to stop and end and move on to the sign test. So you can see the user interface is still fully running. There's a lot of displays and status panels that are still live in the user interface even though we're using the application sequencer. And now it's done with the sign test, and it's running my or done with the random test, and now it's running my sign test. One other thing to mention: if you do have automatic reporting configured, so if you have your test SignalCalc 900 configured to automatically generate reports when the test ends, it still will do that, and you'll have your reports in your specified report folder. So this doesn't circumvent any of the functionality of SignalCalc 900 except for the actual button clicking. All right, and now we're running the second sign test. So in the interest of time, I'm just going to stop this sign test and end my sequence loop so I can move on to the next thing I want to show you. And that is I'm going to get into some simple programming, some simple logic programming in the sequencer. So I'm going to go into my sequence again and hit edit. Window a little bit bigger. And say I wanted to run this sign test and this random test over and over in a loop. So I want to run the random test and the sign test and the random test and the sign test maybe 3 times or 4 times over. Say you're doing some sort of profile cycling, or if you're running a random test, then a mixed mode test, and a random test and mixed mode test, and cycling through different types of loads. That's a pretty common thing to need to do for lifecycle testing. And to do that, I'm going to add a conditional command here. So this is the first time I've opened up the conditional commands menu. And you can see I've got different conditional commands like if and while, and what I'm going to use here is do. So this is do, and then I come to the end of my loop, and the other conditional command loop, and I tell it how many times I want to loop, let's say 3 times. Okay, and so now you can see the whole sequence is encompassed in a do and a loop command. And what it would do, I'm not going to run this in the interest of time here, but it'll open up the random test, run it, then open up the sign test and run it, and then it'll decrease the loop count here by 1 and go and do the same thing over and over again until it hits 0. Okay, in the interest of time, I'm not going to run this, but I'm going to move on to the next topic, which is talking to external devices. The most common external device you would talk to is a thermal chamber. So any other lab equipment like a thermal chamber, or if you're running some tests on the device under test and you have a status signal from that, an altitude chamber, any other external device that you want to run concurrently with the vibe test, you can talk to through the relay card. I'll go into details with relay card in our next webinar, but for this particular webinar, I'm going to open up a sequence that I've already pre-programmed and saved. And in this sequence now, I have an open test command, then I run the test, and then I have two new commands here, write relay state and wait for relay state. And these are how we talk to external systems. So the configuration here is, let's say I want to run my random test, and then I want to give a signal to my thermal chamber to heat up, and I want to wait for my thermal chamber to finish heating up before I go to my next test. That's when I would use these two commands here. So I run my random test here, I initialize, I start, I end, then I write a relay state, which is, sending an output through the digital I/O card. And then I sit here and I wait for one of the inputs on the digital I/O card. So waiting for a signal to come back from the thermal chamber indicating that it's at temperature. And then I go on and run my next test, just as I normally would. So to do this, I'm going to enable my relay card. Again, I'm not going to go into details on the relay card in this meeting, but we're going to see its use here at the top. We have a digital readout of the actual relay card. So I have inputs and outputs, and we're going to see as we execute the sequence, we're going to see that when I had the relay write state, it's going to set the first output to be green, and then when it waits for the relay, when I set the first input to be green, we'll see that, and the sequencer will continue. So let me hit execute here. And so it opens up the random test, starts it. As the random test completes. So while this is running, the relay card is a digital input output, so it can just take a solid either 0 volts or positive voltage for on, 0 volts for off. So it's just a really simple interface, but the ability to read it and execute different commands on it based through the application sequencer is what makes this a powerful combination. So now the test is going to stop. It's going to complete. We're going to end the test, and then we're going to hit the write relay state command. So now my relay card output viewer here at the top, we can see the output. The first output is positive, is green, and it's waiting for the first input to be green to go high. So waiting for it. We've signaled the thermal chamber, hey, get to temperature, and now we're waiting for the thermal chamber to signal back that it's at temperature. So I'm going to just connect a positive voltage to that terminal, hit apply, so we can see the readout turned green and the application sequencer proceeded to the next command. And now we are running our sign test. All right, again, in the interest of time, I'm going to stop this test from running and move on to the last item I want to introduce, and that is the scripting ability. Quickly go back to my slides here. So the application sequencer files are actually saved as text-editable scripts. So I could take that sequencer file that I saved, or that I would save, or that I would open in the sequencer, and open it in Notepad, or in my case, Notepad++, whatever your favorite text editor is. And what this allows you to do is you can copy and paste lines. You can build up your own logic in Notepad. So you don't have to go through all the button clicks. A lot of times it's just copying and pasting and changing the test name, or changing the relay card input output number that you want to do, and that you can do much easier in Notepad than in the user interface for the application sequencer. So with the application sequencer scripting, you can quickly build up really complex logic that would, if you're building it in LabVIEW or building it in using another tool to try and sequence to build out your programmable logic for your vibration test, it could take a long time to do that. Where in a sequence script, it's just 20, 30 lines that you can build up rather quickly. So what I'm going to do here is I'm going to show you. I'm going to open up a sequence script that has some logic built in, and then save it out and edit it in Notepad. Open it up in Notepad and edit it, and show you how quickly you can expand your logic to meet your requirements. So I opened up this sequence script 2, and just to show you what it actually does, first it writes the relay card state 0, the first bit. So it sets, for example, sends the thermal chamber, hey, get to temperature. Then we wait for the thermal chamber to signal back that it's at temperature. Then it opens a random test and runs it. And then while the test is running, it's going to run this sequence loop or this logic in here. So this while master stop available, that is basically saying while the test is still running, while I can still click the stop button, then I'm going to check my relay card input 1, check my relay card input 2, or check my card relay input 1 and act if it's positive. So for example, if I had say I had an error bit coming from the thermal chamber connected to my relay input 1 saying, or relay input 2 saying, hey, if input 2 if there's an error with the thermal chamber, I'm going to set this particular bit to be a positive voltage. Well, this sequencer will continually run in a loop, and if that ever detects it, then we can have some logic to handle that. And you can connect, multiple systems, not just thermal chamber. You could have a device under test if you're monitoring for some voltage on your device under test, and you want to stop the vibe test as soon as your device under test fails, or you have a thermal chamber or a altitude chamber. Any number of external devices can be monitored here. So I have the logic here for one particular device program saying if relay card bit 1 then is a positive voltage, then execute this logic. Now what I'm going to do is open up this sequence loop in Notepad, and I've done that here. So my sequence script 2 is open, and what I'm going to do is I'm going to add a lot more logic. Say I have 2 or 3 devices connected to my relay card, and I want to monitor on each of those relay card inputs and act, and stop the vibe test if any of them goes positive or gets a positive signal. I'm going to do that here. So this is the relay card script, the same sequence file opened up in script. So you can see the commands are pretty logical. Write relay bit 0, wait for the first relay card input to be set high, a positive voltage. Then we're going to open the random test, initialize, and start the test. Now, in this case, this is the case where I don't have the wait for completion on the start test command. So I'm going to actually move my end test command to after my logic. But basically, I'm going to start the test. And after starting the test, I'm not going to wait for it to complete. I'm going to immediately go into this loop that monitors the relay card for my external aborts. So this first abort says if the first relay card bit is, if the second relay card input 1 is a positive voltage, that's an abort. Then I'm going to set one of my relay card outputs to be positive, signal my thermal chamber to shut down, stop, and end the test. Now I'm going to just copy this line and paste it a couple more times, and then modify it. So let's say I've got another device connected to relay card input 2 and another device connected to relay card input 3. Well, now I'm going to be monitoring all 3 of those relay card bits, and if any of them goes positive during my test, I'm going to stop and end the test and abort the test. And this whole loop is going to execute while my test is still running. So while the test is running, it's going to execute all this logic, and then at the end of my test, if the test completes, then I exit this while loop and I just end my test normally. So all of this logic is going to be built into and execute in that sequencer script as soon as I save this. Save as sequencer script 2 with logic.sqs. Save. All right, and there it is. And so here is all my logic. So let me clear my relay card bits and reset my relay card. And then I'm going to execute this test. So now it's signaled the thermal chamber to turn on, waiting for the signal back from the thermal chamber. Let me set that. Now it opens the random test, initializes, and starts. And now it's running through this logic in a loop while my random test is running. So if ever any of my relay card bits 2, 3, or 4 inputs get set to a positive voltage, that indicates something is wrong with one of my external systems, then it's going to execute the stop logic built into that particular for that particular relay card input. So for example, let me set my my third relay card input to be a positive voltage. All right, so now you can see it's positive. Now that tripped my logic here, and it stops the test, ends the test, and aborts the test. So you can see with this sequencing sequence scripting, it's really easy to create some pretty custom logic that you can then use to automate a full test lab. You can use this to automate your entire vibe test, including your your thermal chamber, any other devices that you might have. You might want to monitor and abort the vibe test based on. And you can even configure this to tell the thermal chamber to shut down or any other systems to shut down in the case of any abort on any of the systems. So it's a pretty powerful tool that is meant for it's meant for more than just sequencing tests. We call it the app sequencer, but it's really meant for full lab automation at the largest level. At the smallest level, it's just sequencing test A and test B, but it's got all the tools in there to be able to sequence tests and incorporate all of your lab equipment and control everything all in one place. All right, with that, I'm going to end the presentation. Thanks for watching. If you need to have any questions about this or any other functionality in SignalCalc 900, feel free to reach out to me. My name is Raman Sridharan, and I'm a Vibration Control Product Manager. Here's my email address, raman.sridharan@dataphysics.com. And you can find a lot more information on our products at dataphysics.com.